Hey guys, so today we are going to start a new playlist on data structure and algorithms. So in coming videos I will cover all the data structures and algorithms. So first we'll start with arrays because in many data structures we are going to implement them by using arrays. So we'll start with arrays here. What is an array? An array is a data structure that is used to store multiple same values in a single variable. Multiple same values. As you know, we store many same values. What is the same value? Same value is nothing but if I create an integer array, then I can store only integer types in it. If I create a string array, then I can only store a string values in that. Okay, so here the next point is we can declare or define an array as given below. As you know, in Java I'm using mostly Java in this tutorial. So first in Java we declare an array in this manner, that is int array. This is a reference name and a square bracket. Okay, so this is okay. Next point is an array is a set of ordered data items with a fixed size. Fixed size. This is like I have created here an array. It is an int array with the size I have given as 5, and there is a string cars. That is string array with the cars as a reference name, which has size of a 3 because I am storing only three values here. So what happens here is once I declare or define an array with a size, I cannot change its size. For example, in string cars, if I want to add one more value, then what happens is it won't allow me to add one more values. So we have to create one new array of string cars and copy all these value in that new array should be of increased size or increased length. Okay, so here I have given an example that is of single variable and how arrays. So this is a single variable bucket, that is string name equal to Pawan. So I can store only one value, and here array of strings, or here I have taken a integer array. So array of integers, I can store multiple integers. Okay, so let's move towards the next point, that is every element occupies the same amount of space in the memory. What does this mean now? Every element occupies the same amount of space in the memory. It means that consider this is an integer array here. So what happens is uh, what is the size of an integer? That is of 4 bytes, right? So each bucket is of 4 bytes here. Each bucket is of 4 bytes. So it won't allow any other like long, any other data types like long or double to store in it. It will throw an error. So a compile time error. So that's why here it is given like that. Every element occupies the same amount of space in memory. Integer will have a same amount, each bucket will have a same amount. So then question arises here, what about objects in an array? Because as you can see here, string is an object. String is a class which we create objects of that. So we can't just store, because these strings can be of different size. If I take one more value, that is Volkswagen, then it is of different size. This Tata is of different size. So in this case, in case of objects, what we will do is we just it will just store a reference of objects. not the values of objects. Values are stored in a different memory location, whereas reference are stored in an array. So this is a difference between a primitive and objects. In case of primitive, it stores the values, but in case of objects, it stores the reference. So when arrays should be preferred. So by knowing the advantages and disadvantages of array, we can know when it should be preferred or not to prefer. So here the first point I have given, you can access an array element randomly using index. As you all know, it is index based, array is index based. So we can retrieve any element from an array using their index. These are the indexes. Okay, how these are stored and how we can retrieve by using this index, I will tell in next slide. Okay, so arrays allocate memory in a contiguous memory location for all its element. As we all know that it stores these values in a contiguous memory location. What is contiguous memory location? It means continuous. Like for example, I have taken a bogus memory address, that is 100 for this 0th element. Consider this as a memory location. So first memory, if it starts with 100, then next will be 101, 102, 103. This will in this manner it continues in a continuous manner. Okay, so arrays are of fixed size, as we have seen in our previous slide, that is, it is of fixed size. Once declared, the size of an array cannot be changed. Insertion and deletion operation is quite difficult, as elements are stored in contiguous memory location, and shifting operation is costly. Okay, so this is like insertion deletion operation is quite difficult, because what happens here is, if I want to just insert at this position, that is 102, and after C and before E, if I want to store one more value, then what happens is I have to shift all these elements, all these values which are after C. Like E, I have to shift one more in another memory address, that is 104, and then I can store a preferred value in this. So this way what happens is, it will, if here we have only 4 sized array, so it is not difficult. But if for example take an array of 100 size, then what happens if I want to store a new value at a 50th position? So I have to take after 50th position, those another 50 values which are after the 50th position, I have to shift one by one to the next memory address. So that is costly. Here same in case of deletion. So whenever retrieval operation, if you want retrieval operation to be fast, then we can use arrays, but not in case of insertion and deletion. Okay, so how array elements are retrieved using index. As you can see here, arrays, I've taken an example. So how elements are stored in an array? First we'll look into this. If an array starts at memory address X, in a previous slide I've shown you taken bogus memory address, like these are the memory addresses. It will be contiguous. So I've taken same. So consider this as these 100, 101 as X, and the size of each element in an array is Y. Size is Y, that is integer size will be of 4 bytes. So consider this as a 4 byte. For each bucket will be of 4 bytes. We can calculate the memory address of ith element using the expression of formula, that is x plus I into y. Okay, so x is our address, I is index, and y is this one size of buckets, that is for integer it is of 4. So I have taken an example here. If we know the index of an array, time for retrieval of element in an array is same. So what does this mean? If we know the index of an array, time for retrieval of an element in an array is same. That is, consider this array. If I want to retrieve this element at a 0th index, it will take the same time as if I want to retrieve the element at this 3rd index. Retrieval time will be same for these elements. No matter if it is of size 100 and I want to retrieve the 100th index of an array, then I can retrieve it at the same time. It will take the same time to retrieve as it takes for a 0th index. So how this is possible? Because of its contiguous memory allocation, it is possible. So I have given an example here. Consider address of an array, that is how these addresses are calculated. So I have shown here. So as we know the expression already, that is x plus I into y. So we can take 10, consider for example these are bogus memory address I have taken. So consider address as 10, then this x as 10, then 0 into 4, that is 0th index, and 4 is a byte, that is the size of the index, size of the array, first array, that is 4 bytes. Because it is integer, we have taken 4, so first address will be 10. Next, only index is changing here, address will remain same. Say as it is an integer array, size of array also remains same. So these are the memory addresses of each bucket. So we can retrieve an element from an array at any index by calculating this memory address. It internally calculates, we just have to pass the index, it will calculate the address and get the value. So this is how an array element is retrieved using an index. So thank you guys, and this is my first video on YouTube, so hope you like it, and please like, share and subscribe my video. And coding for this array we will start in the next video, and please also comment on my video so that I can improve myself in the future. Thank you.